This lesson covers the basic relationships between the center of gravity, G, and the center of buoyancy, B, under the action of external forces. In reviewing this relationship, you will learn how the righting and the capsizing tendencies of the unit are generated.
Positions of G and B while in stable state. Now we click 3 times on the point A to apply an external force on the unit. Observe the position of B and G. In applying external force on the unit, the center of gravity has moved to a new position. True or false? Correct answer is false. When an external force acts on a unit, its center of gravity stays in the same position.
The separation between forces at G and B has generated an internal moment that is counteracting the external force.
Now we see the direction of the counteracting moment.
The internal moment that counteracts the external force is a couple moment, referred to as the righting moment, Rm. The resulting moment couple that counteracts the external force is delta times Gz, or W times Gz, where Gz is the righting moment arm.
Now we click at point A to release the external force and see what happened.
The distance between the two forces at G and B has generated a righting moment, Rm, that brought the unit back to its upright position.
Position of G and B while in neutral state. Now we raise the center of gravity, G, to a higher position. Given the new center of gravity, G position,
with a new G position, you have caused the forces at B and G to be in line.
when the center of buoyancy, B, is in line with the center of gravity, G, the correct expression for the righting moment will be. Correct answer is 2. When G is in line with B, the righting moment W times Gz is 0 because Gz equals to 0. Position of G and B while in unstable state. Now once again, we raise the center of gravity to a higher position. Referring to the shown direction arrows, to which direction will the unit incline? Direction L or direction R? The correct answer is direction R.
When the center of gravity, G, is outboard to the center of buoyancy, B, the resulting couple moment W times Gz, or delta times Gz, tends to turn the unit further toward the direction of inclination. For purpose of illustration, the force at point A restrains the unit from inclining further. Note that while by definition the unit is considered unstable at this inclination, it does not necessarily need to capsize.
Position of G and B at the lull angle. Now we click at point A to release the restraining force.
Depending on both the shape of the hull and the height of the center of gravity G, if the center of buoyancy B moves out further than G, the unit achieves a new equilibrium condition. The inclination angle at this condition is known as the lull angle.